So the first one, if we look at something like number 3, it says cosine of 7 pi over 20. And the instructions say express as a cofunction of a complementary angle. Very simple. Don't make this harder than it is. Cosine of one angle, acute angle in a right triangle, equals the sine of its complement, which means sine of pi over 2 minus 7 pi over 20. And then all we need to do is simplify that and we're done. We don't need to find a value, we don't need to do anything. All we're doing is ask to re-express this in a different form. So this is the same as 10 pi over 20 minus 7 pi over 20. So it's equivalent to sine of 3 pi over 20. All right? And that's all you're asked to do. So if you look at the exercises from that section 1 through 4, that's all Swakowski and Zelke is asking you to do. Then 5 through 10. 5 through 10 has to do with, just like we did with the angle I showed you where pi over 12, you're asked to do the same thing. And they give you don't have to come up with the difference that equals the angle or the sum. They give you the angles. And then all you have to do is plug things in. So for instance, number 9, 9a, you're just given sine of 3 pi over 4 minus sine of pi over 6. Now there's nothing to do here. This is not a sign of a difference. You do not use an addition subtraction formula here. This is just simple trigonometry. What is the sine of 3 pi over 4? It's root 2 over 2. What is the sine of pi over 6? It is 1/2. So if we combine these, the answer is just root 2 minus 1 over 2. There's no identity to use on this. But that's not the same thing as part B, where part B asks you to find sine of 7 pi over 12. Well, 7 pi over 12 is the same as 9 pi over 12 minus 2 pi over 12, which you'll notice when we simplify these is 3 pi over 4 minus pi over 6. Aha! These are the same angles as these. So is the answer that? Please tell me no. Please say, no, Mr. Selke, the answer is not that. This is a difference of signs. It's not the sign of a difference. The sign of a difference requires that I expand using the subtraction formula, which gives me sine of 3 pi over 4, cosine of pi over 6, minus cosine of 3 pi over 4, sine of pi over 6. Well, sine of 3 pi over 4 is root 2 over 2. Cosine of pi over 6 is root 3 over 2. Cosine of 3 pi over 4 is minus root 3 over, minus root 2 over 2. And sine of pi over 6 is 1/2. So simplifying, common denominator is 4. First numerator becomes root 6. Negative times negative is a positive. And I'm left with the sine of 7 pi over 12. Root 6 plus root 2 over 4. Notice it doesn't look anything like that. All right? So again, he's just trying to make a point with you. Sine of a difference of signs is not equal to the sine of a difference. Okay? Don't do it. It's a mathematical mortal sin. 11 through 16. These problems are asking you to put the question or put the statement back together. In other words, express as a single, as sine or cosine of a single angle. So, how do they work? Well, let's try one. If we look at number 15, we're given cosine of 3, sine of negative 2, minus cosine of 2, sine of 3. Now, are the two angles here the same as the two angles there? They're not. So I cannot use the addition-subtraction formula right away. I've got to do something. I have to make the two angles here match the two angles there. Well, a couple different ways I could do that. Let's take the negative sign out of here. If I do that, I get minus, right, sine 2 cosine 3 minus cosine 2 sine 3. Now I've got a negative and a negative. Can I factor it out? Yes, I can. So I can write this as sine 2 cosine 3 plus cosine 2 sine 3. Well, now when I look at that, isn't that the form of sine of alpha plus beta? So what are my two alpha plus, what are my angles, alpha and beta? Well, they're 2 and 3. So this becomes minus sine of 2 plus 3, which is minus sine of 5. Again, if you were to think of it, this is a good answer. If you didn't choose to do it that way, you could have looked the other way and said, well, cosine of opposite angles are equal. So I could make that cosine of negative 2. Now I need to get it in the form, though, that seems to work. And so I would take, if I were to do it that way, I would get sine of negative 2 cosine of 3 minus cosine of negative 2 sine of 3. Well, what does that equal? Well, it's a subtraction formula. So this becomes sine of negative 2 minus 3, which is sine of negative 5. And you go, but those answers are different. No, they're not. Go back to chapter 5 in your fundamental identities, and you know that sines of opposite angles are opposites. So those are equivalent answers. Generally, my advice, get rid of negative angles. I don't like negative angles. I think they just make things more confusing. So the first step, if I see a problem that involves numbers are the same, but the signs are different, I use the negative angle identities in the first step to get rid of all of them. If there's a negative sign that then I can factor out or whatever, if it's negative sign common to both, then I write it that way. But generally that eliminates any confusion. This way, a little more dangerous, a little more risky. But if you do it the right way, you're going to get the right answer either way. Okay? But wait, you're saying, could there be any more? Could there be more fun that I could have? Well, of course there is. So if we look ahead, the next set of exercises takes us down 17 through 24. You have more fun problems that actually give you values in the different quadrants. So again, it's more the same kind of stuff, except you want to draw pictures now. So let's see how those work. So if we jump ahead and look at number 21. 21, we're told that sine of alpha equals negative 4/5. And secant of beta equals 5/3. And then they tell us which quadrant each of those angles is in. So alpha, quadrant 3. So for alpha, we're going to draw a triangle in quadrant 3. So there's alpha. Here's the reference angle. So negative 4 over 5. That means the third side here is 3. 3, 4, 5, common right triangle. Now I look for beta. It says beta is in the first quadrant. So I draw a first quadrant angle, triangle. Here's beta. Secant is the reciprocal of cosine. So if it's given as a reciprocal, convert it. Makes drawing the triangle and labeling it correctly easier. Adjacent, hypotenuse, once again 3, 4, 5. Now that I have my two triangles drawn and the third side's figured out using either Pythagorean theorem or common right triangles, I can then answer all the questions. So for this one, I'm not going to do all of them, but let's look at tangent of alpha plus beta. So tangent of alpha plus beta. Again, from everything we've derived so far, that's going to be tangent alpha tangent beta over 1 minus tangent alpha tangent beta. Now again, trig functions are ratios. So tangent of alpha, I'm going to look at this triangle. Opposite over adjacent gives me 4/3. Tangent of beta, opposite over adjacent, gives me 4/3. 1 minus 4/3 times 4/3. Beautiful stuff. 4/3 plus 4/3, 8/3. 1 minus 4/3 squared is 16/9. So what do we get? Well, 8/3 divided by 9/9 minus 16/9 is negative 7/9. So we're going to multiply by the reciprocal. I get 8/3 times a negative 9/7. 1, 3. And I get negative 24/7. Beautiful stuff. So tangent is negative. That means that alpha plus beta is either going to be, the sum of the angles is either going to be in quadrant 2 or it's going to be in quadrant 4. In order to determine which one, my guess would be quadrant 4, since this is an acute angle, first quadrant angle, this is a third. We add them together, probably over there. But if you found a second trig value, either sine or cosine, you could for sure determine the quadrant of alpha plus beta, because we know for here all of them are positive. For here, only sine and cosecant are positive. For here, only tangent, cotangent are positive. And for here, only cosine and secant are positive. So when they ask you, what's the quadrant that contains alpha plus beta, they're asking you that question after they've asked you to determine 2 of the trig values for alpha plus beta. And that's pretty much it. Verifying reduction formulas is more verifying identities. You're going to start with the left-hand side of the expression. You're going to expand using one of the addition-subtraction formulas, and then you're going to simplify it using your knowledge of the unit circle. They will actually, you should be actually pleased because they're fairly easy. Most of these are derived in maybe 2, 3, 4 steps at most. All right? So again, that pretty much takes you through 6.3. There should be enough information there so that you can solve and get through all the exercises from that section. Hope you enjoyed it. Hope you're having a great time. We will see you when I get back, meaning on Monday, the following week. Enjoy, and again, have fun with these identities. Hopefully you've identified with this lesson. Thanks. See you later.
Okay.